LustGarten Foundation has really been a foundation for spurring pancreatic cancer research across America and the globe.
Without LustGarten support, and especially the community, I wouldn't be able to ask big questions or make innovative discoveries.
We aim to understand how glycosylation reshapes the tumor immune microenvironment. We might be able to better design immunotherapies to overcome these limitations, and the LustGarten Foundation has supported this work, and it's critical because this is a very unique area that's poorly understood.
The LustGarten Foundation has supported interactions, I would say, sort of far and wide, interactions within my institute, collaborating across many different domains, working on pancreas cancer, collaborations within my region, across town, local hospitals, other investigators, and collaborators really across the country and indeed around the world, coming together to think about what are the big problems and how we can collectively pursue them together in ways that we really can't do as effectively as individuals.
LustGarten has been really the emphasis of pushing scientists at MSK across the country for continuing the passion and push toward curing pancreatic cancer. There's a long ways to go, but we would not be where we are without the LustGarten Foundation support and focus on pancreas cancer as a disease that we can treat and cure.
LustGarten Foundation, thank you.
Good morning, and welcome to the final installment of LustgartenLIVE, Progress and Promise, our year in review for 2022. I'm Linda Tintawi, CEO, and I'm so glad you could join us. This past year has been a remarkable one. Many studies that are underway and led by LustGarten are allowing research to move forward in ways we couldn't even imagine 5 years ago. We continue to pursue multiple paths to detect pancreatic cancer earlier. Today, you'll learn more about the K-Ras gene a bit later in our program. We've invested significantly in vaccine development and are encouraged by what we've learned. And LustGarten's commitment to fostering diversity in the field is stronger than ever with our lead program, that's LustGarten Equity, Accessibility, Diversity Grant, and our Career Development Awards named for Congressman John Lewis and Ruth Bader Ginsburg. I'd like to thank Scott Drake, President and CEO of ViewRay Technologies, this year's presenting sponsor. Our 2022 series sponsor is Ipsen, and today's event sponsor is Novocure. LustGarten and Novocure share a common purpose to support the pancreatic cancer community, advance research, and raise public awareness of pancreatic cancer. The company develops innovative therapies by advancing clinical trial efforts to extend survival rate. This includes their PANOVA-3 clinical trial that is currently enrolling patients. You can learn more about that trial. There's a link that in your chat box. The LustGarten community is bigger, it's stronger, and it's more collaborative than ever before. Thanks to all of you, we're on our way to transforming pancreatic cancer into a curable disease. We invite you, as our presentation moves forward, to type your questions in the Q&A box at the bottom of your screen, and we'll answer those to the best of our ability at the end of today's session. Now it's my great pleasure to introduce LustGarten's Vice President of Research, Dr. Andrew Rakeman. Andy, you and our guests will have so much to cover today. It's going to be a great session.
Yeah, thank you, Linda. And I'm really looking forward to today. This 2022 has been flying by, and it's been a year that's been capped by a lot of great advances in pancreatic cancer research. And really what I'm most excited to talk about today is how we've seen advances across all of the major priority areas that you outlined. Finding cancer earlier, treating it earlier than ever, discovering new drugs, and finding ways to tailor those to the right patient at the right time. And it's really great, gratifying to see those making headroads in the clinic in all those priority areas while sharpening our focus on what are the scientific areas that we need to focus on to do better in the future going forward. And it's also a pleasure to be able to share it with this community. As you know, really the driving force behind all that we do starts from the patients, comes from this community that supports us so well, but then really is executed through our wonderful scientists that we work with who are so dedicated and so driven. And really delighted today to be joined by two of the best in the business who are going to help me to talk through the advances that we've seen this year. So I'll be joined today by Dr. David Tuvison and Dr. Elizabeth Jaffe. Dave Tuvison is a physician scientist, and he's the foundation's chief scientist. He's also the director of the LustgartenLIVE at Cold Spring Harbor. And if that wasn't enough, he's a Roy J. Zuckerberg Professor of Cancer Research, the Cancer Center Director at the Cold Spring Harbor Labs. And thanks so much for joining us today, Dave. As well as joined with Liz Jaffe, who is also a physician and a scientist, a world-leading immunologist and a real driver of immunotherapies for cancer. She is our chief medical advisor, also runs the Lustgarten Lab at Johns Hopkins University, Johns Hopkins Medical School. And in her spare time is the Dana and Albert Cubby Broccoli Professor of Oncology, Deputy Director of the Cancer Center, and co-director of the Vera Cancer Center of Pancreas Cancer Clinical Research and Patient Care at Johns Hopkins School of Medicine. So Dave, Liz, welcome. Thank you so much for being with us today and being able to share these highlights with us.
Thank you, Andy, and welcome everyone. Thanks for joining our webinar today so we can give you exciting updates on the science and medicine of pancreas cancer 2022.
Yeah, thank you. Welcome, everyone. And I just want to say this is an exciting time for pancreatic cancer. I hope you see all the progress we've made, and you'll see the progress we're hoping to make over the next year.
So great. So Liz, maybe one area that we can start to talk with, one of the areas I've been really excited to see how much new has happened this year is thinking about how do we find pancreas cancer earlier, and then what can we do to treat pancreas cancer earlier? And I think we saw earlier this year a really landmark report coming out from the CAP study, or the Cancer of the Pancreas Screening Study, really showing what the benefit is that if you can find pancreas cancer earlier. So maybe you can give the group today a little bit of background on what CAPS is and why this is such an important result that we've seen.
Absolutely, Andy. This has been a very important study, and the report that came out is the CAPS-5, which was conducted between 2014 and 2021, but it's the fifth study, and I believe they started back in 1998. So this is something that the National Cancer Institute has supported, and the goal is to enroll individuals who are at high risk for pancreatic cancer. And typically this means people who either have a strong family history, but genes can't be found that are make them susceptible to pancreatic cancer, or subjects who do have those genes. And so the goal is really to monitor these individuals who are considered high risk for pancreatic cancer with evaluations, typically yearly, to try to diagnose the disease either at the earliest stage of cancer development or at even a pre-cancer, if that's possible. Not always possible. They're very small, hard to see on most radiographic analyses. But that's the goal. And the goal, the primary endpoint, is the stage that the pancreatic cancer is detected following screening, hoping that instead of finding it at stage 4, which typically that's about 50% of patients, we find the majority of the cancers at stage 1, where we have a very good chance of curing with surgery. So that's really the goal. And so the most recent study that was published enrolled over 1,400 people who were at high risk. And this is 8 centers across the country. So it's a multi-center study. The lead individual was Mike Goggins, who's at Johns Hopkins. He's a gastroenterologist. And what they found was that, well, first of all, 48%, almost half, had a gene that made them susceptible. The other half, again, familial susceptibility, but no gene. It is believed also that eventually additional genes will be found. So up to 20% of individuals could be high risk who develop pancreatic cancer. So this study not only allows us to follow patients and see if we could detect the cancer early when they're high risk, but eventually we may even be able to find additional genes in those individuals who we do not yet have a genetic predisposition. So of the almost 1,500 subjects who were enrolled, I believe 10 patients were diagnosed with pancreatic cancer over a 7-year period. That's how long this particular study was. One of them was metastatic, so that's stage 4. That's not what we want to diagnose, but that patient was the only patient who dropped out of the study 4 years before diagnosis. So maybe had that person stayed in the study, we would have picked up their cancer earlier. 7 of the other 9 who developed pancreatic cancer were detected stage 1. So that's really what we wanted. And then 2 others, one detected stage 2, one at stage 3, still surgically treatable potentially. And 7 of the 9 are alive. So far, there's a median follow-up of 2.6 years. Also, another 8 were detected with what turned out to be high-grade or low-grade dysplasia, so at the pre-malignant stage, and presumably all of those individuals should be cured. If you look at the entire study, so CAPS 1 through 5, as I mentioned, that's been ongoing since around 1998, 26 pancreatic cancers were picked up. 19 were picked up on surveillance, and the others, again, fell off of being followed. Of the 19 that were picked up, 60% had stage 1. So that's, again, very good. And just if you take a look at the entire program, the 5-year survival to date of all of those subjects who developed cancer was 73%, which is, for pancreatic cancer, amazing, since typically we expect it to be around, 1.5 years when you pick up pancreatic cancer. So it seems to me, screening really works, but as you alluded to, one of the problems is even if we screen and can pick up early, it may not benefit the patient. So we need, when we're screening, some opportunity to intervene, or we call it interception, being able to give some sort of treatment that's safe that can prevent the cancer from developing entirely. And that's some of the work I've been doing, as everybody knows. And so we've been developing cancer vaccines for a long time for patients with cancer. And more recently, we realized that since there is a gene, mutated K-Ras, that is the first gene that turns on in the earliest changes in the normal pancreas, it's starting to move toward cancer. We figured, why not try to use the immune system to eradicate the earliest changes so that the cancer can't develop any further? So we call that interception because we can't pick up before that develops. So we know something will change, that mutation will occur. So it's not true prevention, it's really interception when you start to see the earliest changes. And so we first tested a vaccine we developed against mutated K-Ras in patients who had pancreatic cancer who underwent surgery. And we were able to vaccinate these patients, show that the vaccine is safe and that we can induce an immune response against this particular mutation. And we're following those patients. So far, so good, but it's too early to tell how many of them will prevent the cancer from coming back. But that allowed us to ask the FDA, can we go into our high-risk population? And so we went into the patients who are enrolled in this CAP study at Johns Hopkins. And so far, we've been able to vaccinate 5 individuals. And so far, it's been very safe. We just started back in June. And so far, we're seeing evidence of activation against the mutation. So it's not a home run yet. We don't know for sure if these individuals will be able to go on without ever developing pancreatic cancer. But we do believe it's the beginning, and we're going to learn a lot. So hopefully we can even make it better as we learn more about how the vaccine works in people who are at risk for pancreatic cancer. Back to you. I think we may have lost Andy. Dave, did you want to?
Thank you, Liz. That's incredible. Froze there, but thank you, Liz. That's incredible, and I think you're as understated as usually are, but it's really hard to overstate the importance of starting this first ever study of trying to intercept or prevent progression of pancreatic cancer in people who are not yet sick. And as you said, there's a lot to do to really understand, is this something we can do safe? Is it going to be effective? But it's a real turning point for the field in terms of changing that thinking that pancreas cancer is something that starts before the diagnosis, and there's opportunities there to intervene safer. As we saw from the CAP study, you can identify people at very high risk and even with these high-grade dysplasias, but the treatments that requires today are harsh. And if we can move in earlier and treat with something that's safer, more acceptable, we can reach to more people. So very, very exciting. I think we'll be looking, forward. Hopefully this time next year, we'll hear a little bit more about what's happened with those patients and follow up on their immune response. But like you said, it's going to take time to see. A question for you based on this, as Liz pointed out, through these, looking at kind of the tip of the iceberg of who's at risk, who we'll be able to follow through this CAPS program. We show these, tremendous benefits of putting people in surveillance, identifying them early, opportunities to go into interception studies. But I think, as Liz alluded to, there's a lot of people that we can't find right now who are at high risk. Some people have a clear family history, but we don't know the mutation involved, or we haven't found a mutation yet. Not really understanding yet what do those changes in the pancreas that lead to high-grade dysplasia. And this is an area that the foundation has kind of doubled down on recently and launched some new programs around. So maybe if you want to talk about some of our new projects to understand the earliest events of pancreas cancer and what we're doing there.
Yes. I want to thank Dr. Jaffe for a terrific presentation on some recent findings in our field. The study she mentioned from Dr. Goggins at Johns Hopkins has been a study that's been going on for 2 decades, and really has read out recently, showing the tremendous benefit of intensive monitoring patients who are at high risk for developing pancreas cancer, as defined by having first-degree relatives with pancreas cancer. Something that came to our attention over the last several years is many of the families who are at high risk for developing pancreas cancer, we actually don't know the genetic cause for this. And this was surprising to me, and I think to some of my colleagues to hear this. But fortunately, we have modern and newer ways to look into the genome to try to identify what might be the risk alleles that people inherit from their parents, which can put them at higher risk for developing a pancreas cancer. So as you all know, we are animals that exist because we have organs and tissues and cells, and each cell is a nucleus, and the nucleus holds DNA. And so the DNA is the computer of your cell. And we have 3 billion sequences in the DNA, that actually 3 billion nucleotides that encode the instructions for making a cell, a tissue, an organ, and a person. Changes in those 3 billion are what give rise to cancer if you have a higher risk of inheriting the cancer. The way we have looked into the 3 billion nucleotides in the past is we sequence bits of the 3 billion on machines where we get a stretch, like a stretch of letters. And then we use a computer to reassemble the bits. And so it's like making a quilt from little bits of information. In the end, we make a quilt, but the quilt oftentimes is missing information. And we have newer ways to sequence the 3 billion where we could, for example, instead of giving a short stretch, get a very long stretch. And instead of 150 base pairs, get 15,000 base pairs. And you would ask, well, what's the point of having big pieces of quilt versus small? Well, the real point is that you'll see things in 15,000 that you will never see in 150, because there are changes that can occur in our DNA that, the past methods would never see. So it's fortunate that we have these newer ways to look at DNA. And we have these great banks of samples at Johns Hopkins and elsewhere in our country, where patients' families have been followed very carefully for risks of cancer, including pancreas cancer. And so we have a new project where Alison Klein, who's a molecular epidemiologist and molecular biologist at Johns Hopkins, is leading a project on assembling new information from families who are at high risk for developing pancreas cancer, for which we don't know what the gene might be. And so the genes that we know are involved in pancreas cancer are genes like BRCA2 and P16 and STK11. And there are a variety of other genes too. But again, we're missing about 80% of the answers. And so Dr. Klein and her colleagues are actually going to very carefully do long read sequencing and other methods to try to find in the genomes smoking guns, which could be genes involved in pancreas cancer. You could ask, why bother? Well, the reason why we bother is the genes actually help tell us about how the cancer starts. And if we can understand how the cancer starts, Dr. Jaffe and her colleagues and the folks that we support in the Lustgarten Foundation can actually invent approaches to actually ameliorate the effects of those genes. And so Dr. Jaffe had a terrific, exciting update for you on the work she's doing to vaccinate people at high risk for pancreas cancer, to try to enable the immune system to go out and gobble up the cells that have mutated K-Ras proteins. And these are the cells that we think are the ones that give rise to the actual pancreas cancer. Well, if we were to provide her with other candidates, she would develop another immune therapy approaches to go after those targets. For example, that would be one thing that we could learn from this. Other things we could learn is there may be genes involved in pancreas cancer that actually don't themselves work in the cancer cell, but work in the tissues around the cancer that promote things like inflammation. And we know that inflammation of the pancreas is a risk for developing pancreas cancer. There's a disease called pancreatitis that you've all heard of. And there are certain genes you can inherit that promote pancreatitis. And so it may be that we actually pick up new pancreatitis genes in this work that Dr. Klein and her colleagues will be undergoing. And that would, again, open our eyes to how we would specially monitor such families for the occurrence of pancreas cancer. And so we have one brand new project that Dr. Rakeman mentioned, what we're very excited to support with Dr. Klein. We have another project which is really related to what Dr. Jaffe said. It's like, if we could see what early pancreas cancer looks like, couldn't we design better weapons to go after it? You've heard from Dr. Jaffe, she would like to immunize to the early cancers and make them, go away so that the real cancer never shows up. And that is a fabulous idea. That's the concept of a tumor vaccine. We have tumor vaccines currently available in society. The best example of one is the papillomavirus vaccine, which can prevent cervical cancer and head and neck cancer. And it's available in many countries throughout the world, including our own. It's not a law that your children have to be vaccinated, but I would say most educated people make sure that their children are vaccinated because this is a disease you can prevent. Now, could we get a papillomavirus for pancreas cancer? That would be great, a papillomavirus vaccine. And so Dr. Jaffe has, the shot she's going after, which she can measure, which is K-Ras. Are there other things? Well, to actually design such studies to go after the early cancers, what we need is to have a better understanding of that early cancer. And it turns out that there are additional investigators at Johns Hopkins who have been making models of early cancers by taking the tumor when it comes out of a patient and slicing through the tumor very finely in slices so fine that you couldn't do it at home in your kitchen, and recreating what the tumor looks like at the earliest stages. And so a pancreas, again, is something that most of you have never seen. It exists behind your stomach, so you can't feel it with your hands. It's an organ that its job is to balance blood sugar and allow you to digest food. The cancers come out of the ducts in the pancreas, which are these serpiginous, meaning snake-like ductal structures, little tubes that the digestive enzymes dump their contents into to get into your intestines to allow you to digest food. In those ducts are where the little cancers occur. And this model made by the investigators at Hopkins, led by Dr. Laura Wood, a very talented pathologist, and Dr. Denny Wirtz, who's a bioengineer at Johns Hopkins, have actually enabled us to see for the very first time what early pancreas cancer really looks like in humans. And it's amazing what it looks like. We see in these ductal structures little tiny pannins, P-A-N-I-N, which is kind of like panini without the I. These are the early pancreas cancers. The early pancreas cancers, they're common and they're bad. They're bad because they're the ones that give rise, we think, to the invasive cancer. And so we're trying to learn now about the biology of these early pancreas cancers. They're like as big as a grain of rice, really tiny. And we've never really had a chance to think critically about it. And so we have this model that Dr. Wood has created that's going to allow us to go deep on the biology, understand what are the processes involved in allowing the PANN to arise, so that she and her colleagues and all the folks who work on pancreas cancer can develop new ways to understand and target these early cancers. And if we have new ways to target them, these will be something we can take into the clinic. So collectively, we'll have a better way to detect early cancer and to treat early cancer so that we prevent or intercept the ability of that to become a bad problem for our patients. So I'm really excited about both of these projects, as you can tell. And I'm so glad that the Lustgarten Foundation, through your support, has enabled us to go after them. So back to you, Andy and Liz.
I think we continue to have some issues with the internet in the Lustgarten office. So Andy is frozen. So Liz, if you want to kind of unmute yourself and pop in. Oh, is Andy back? Not sure. Liz, I'm just going to ask you to unmute yourself and go ahead and hop in and address some of the things that Dave was just discussing. That'd be awesome.
Now,
I think Andy's still trying to come in. I think everything that Dave mentioned was very important, because we have a vaccine that we think can prevent the cancer from developing, but I really need to be able, at the earliest time point, to be able to know who is eligible for the vaccine. And although we have some genes that tell us about 10% are high risk, we really need to learn more and figure out who the other probably 10% are. And we need to understand, we also need to communicate to the community that we have something available so that people undergo screening. So many people are fearful. They have family members who have developed pancreatic cancer, but they haven't seen a gastroenterologist who's an expert in screening for cancer, for pancreatic cancer. So I do suggest that those of you out there who may know family members, who have been diagnosed with pancreatic cancer, you may want to consider at least speaking with a gastroenterologist about screening. And I know there was a question in the chat about that. So yes, that's what I would do. And I would have even children screened when they're in their, late teens, early 20s. But again, screening is something that you need to discuss with a expert, because there are some ramifications of learning if you're at risk.
Thanks,
So
Liz.
you should discuss it.
Thanks. I don't want to upend Andy's flow, and I'm not 100% sure what he wanted to discuss. So I'm just going to jump in here and ask Liz and then Dave. What I'm so excited about is the fact that we are moving so much of the science that Lustgarten has funded for 25 years in the lab, and that so much is now coming into to the bedside for patients. So Liz, if you could talk a little bit about our Clinical Accelerator initiative and why that's so great for our community and our patients and so exciting.
Yes, thank you. So we're very excited to have the opportunity to initiate a clinical trial accelerator program. And we named this after Robert Vizza, who was the original CEO of Lustgarten, who helped to really jumpstart the organization. And a lot of money has been invested over the past 2 decades to really understand pancreatic cancer. And that was very important, because without understanding it, you can't develop new therapies. But with these 2 decades worth of information, and we are at a time where the technologies are really informing us very quickly about what are the different signals in a pancreatic cancer that suggest they'll be resistant to a type of therapy, but maybe sensitive to another therapy. What are the signals that help the cancer to metastasize from the pancreas to the liver? So these are all important information. Once we know it, we could develop drugs and drug strategies to be able to treat these patients. And so we have a group that represents the major cancer centers all over the country. We call this our advisory group. They're experts in this disease. And we survey people at our institutions as well as elsewhere throughout the country to see if they have some interesting data to support an early clinical trial. And so the whole point of this Accelerator program is to support early developments in patients and to understand if these developments are of any benefit. These are small studies, they're very rapid studies. We learn a lot from these studies. And if something looks good, we can take them to a larger study and try to get them approved for standard of care. And so over the past couple of years, we've been able to already approve over 6 studies that are in different stages of enrollment. And we have another series of studies that are already on the books that we're considering. And they range from drugs, combination drugs, to immunotherapies, to vaccine therapies, to other targeted therapies. So we're looking at everything, and we're looking at all stages of pancreatic cancer. So early surgically treatable stages, locally advanced where surgery is not an option, but it hasn't gone to the liver, as well as metastatic disease.
Very exciting. That's what I know, what gives our patients so much hope and their families. Dave, could you talk what's unique about the Lustgarten Foundation is our labs program. So Lustgarten advancing breakthrough science through our 6 labs across the country. We added a 6th one this year at the Salk, our first one on the West Coast. Very excited to have them in the Lustgarten family. So Dave, if you could talk a bit about why our approach with the labs program is so important to advancing the science.
You bet. Thanks, Linda. The labs program, which Linda has mentioned, is an extremely important program that the Lustgarten supports, where 6 investigators across the country and groups are able to concentrate on the topic of pancreas cancer at a very deep level, enabling them to try things that they couldn't otherwise have the opportunity to do so. And so, for example, in the labs program, my own laboratory at Cold Spring Harbor was able to develop a model system, which are called organoids, about 9 years ago. And this model system has enabled us to look very deeply into human pancreas cancer specimens to study the pathways that are perturbed and to look for new medicines which may be able to stop the organoids. This project actually has led to a clinical trial, which Dr. Jaffe leads the trial in the United States, and we have another leader of the trial in Canada, Dr. Jennifer Knox, which is a randomized trial comparing the 2 types of systemic chemotherapy used for patients with advanced pancreas cancer, asking, is either medicine better, but also at the same time asking, would the organoids have picked the right medicine for a patient? And this trial is over half accrued right now. And so it's a very exciting project that we share throughout the labs program, because multiple sites in the United States are clinical partners in this. Johns Hopkins, Memorial Sloan Kettering, Northwell Health here in New York, where Dr. Dan King is the PI, Dana-Farber in Boston, and then in Canada, where Dr. Jen Knox is in charge of the program at the University of Toronto, and she has some additional sites in British Columbia, for example. This is an example of how a fundamental question in a Lustgarten laboratory, where we didn't know if a new model system would matter, if it would be helpful, the basic science got developed, the methods got developed to a point where we thought we were learning things about human pancreas cancer, and we were able to actually launch a very large trial to ask a very profound question. So in some ways, it mirrors the approach that Dr. Jaffe is taking with the clinical trial section in our Lustgarten Foundation, where she is doing smaller trials, asking very deep questions about a new idea. This is a larger trial where we're asking a deep question about a technology, because if the technology turns out to be useful, obviously it would then be used for all the other studies that you hear about. And this is just one example, from my own laboratory. I'm a labs member, but as part of what we've done at the Lustgarten is we've expanded the labs program. It includes a very deep effort by Dr. Jaffe at her laboratory at Johns Hopkins, and another individual, Dr. Bert Vogelstein, who's a geneticist at Johns Hopkins, who's made some of the seminal discoveries on the genes involved in pancreas cancer and ways to detect pancreas cancer in blood. We have a program at MIT that Tyler Jacks directs. He was the handsome fellow you saw in the movie early on. And he's a premier cancer scientist in our country. And then finally, Dr. Brian Wolpin, who directs the Hale Center for Gastrointestinal Oncology at Dana-Farber. And Brian focuses on early detection, risk stratification, and also novel therapies for patients. And so those are, I just mentioned 5 of the 6 lab programs just now. These are large groups led by, real thought leaders in pancreas cancer research. They are supported at a level where they can be fearless with their questions, or they can be impatient in trying to accomplish their questions, because we all share this common goal of putting ourselves out of work. And we can only put ourselves out of work if we actually make these breakthroughs such that you all don't have to go on webinars. You already know that pancreas cancer is sorted. All we're telling you today is things are looking much better, and it actually is true. And it's really because of Linda and her group at the Lustgarten Foundation with Dr. Rakeman in supporting the labs program and the clinical accelerator initiative, et cetera. We have one more program, which I'll tell you about if I haven't run out of my meter here, which is a program we started at the Salk Institute. That's located in San Diego. And it's one of the think tank campuses in our country, where it's an independent research institute and has 50 professors. We actually have worked with investigators at the Salk over the last 15 years. And it got to the point where they were doing so much pancreas cancer research that we said, why don't we codify their efforts in such a fashion that we're ensured that they're going to focus on pancreas cancer, for the next handful of years. The Salk professors have done things like discover how signaling works in cells. There's something called tyrosine phosphorylation. Tyrosine is one of the 20 amino acids. Tryptophan is the one you've heard of because you think when you eat turkey, it makes you sleepy. Tyrosine is another one. Tyrosine is cool looking. If you were to look at the structure, Tony Hunter figured out how tyrosine phosphorylation was an electric switch in our cells. He works on pancreas cancer for the past 10 years, and he's, an eminent scientist in the world. And we're getting him to work on signaling in pancreas cancer by supporting a program at the Salk where he's finding new mediators of signaling cascades. Ron Evans, another similar, very famous scientist, figured out how retinoic acid works. Retinoic acid, you need it because in your eyes, that's what the switch, when light hits your eyes, that triggers in your neurons eventually that you see things. So Ron actually figured out how the retinoic acid receptor worked, and you need this for differentiation of cells and biology of cells. He's worked on similar concepts of how ligands, how small molecules cause changes in proteins that make the DNA I told you about early turn into genes. So again, you have DNA encode genes encode proteins. Ron figured out how actually biology communicates with the computer chip so that the cells are made. So Ron works on signaling pathways in the nucleus that tell us about health and about pancreas cancer. Ruben Shaw is the director of the Cancer Center at the Salk. He's a metabolism expert. Metabolism is part of life. It's mostly part of health, but in cancer basically twists health a little bit. That's all cancer is like a slight version of health. And in cancer, the cells are hungry, and so they steal nutrients from the cells nearby. And Ruben has identified pathways that the cells use to steal those nutrients from the cells nearby. And by doing so, they make the cells around them unhealthy, cause a disease called cachexia when people lose a lot of their vitality. And Ruben is studying pathways in pancreas cancer cells that are metabolic pathways altered. And then finally, Danny Engel was the gal who was on the movie early too. And so she was at our advisory board meeting just a few months ago, and she works on pancreas cancer. She studies sugars. So sugar, you think of, you shouldn't drink too much of it in the sodas. Well, actually, sugar is mostly good. And sugar is on the outside of your cells, just like the shingles are on the outside on your roof of your house. Sugar is critical to giving structure to proteins that are outside outside cells. It turns out in cancer, as I said before, is greedy metabolically. It's also lazy. And so it sheds things that take a lot of energy frequently. And there's a sugar change in cancer cells, which we call CA19-9. You all have heard of this, is a blood biomarker for pancreas cancer. Essentially what it is the pancreas cancer cells have gotten lazy and they decided not to work so hard to make a fancy structure. Turns out this is critical because CA19-9 is a biomarker for pancreas cancer, but Danny discovered was a promoter of pancreas cancer. So she works on a really exciting aspect of pancreas cancer at the Salk, and the 4 of those people together are the Salk program. We're so excited they're working on this together. They get to argue with each other, help each other in efforts to make everything go faster. And so this is a new labs program, and I know I took up a lot of time to talk about the labs program, but these are kind of like our all-stars. And they give ideas to the clinical trials group. They give ideas to the foundation about what we should work on next. And in many ways, you are supporting the labs program, even though you may not have met those individuals. These are sort of our all-stars. And thank you for doing so. So Linda, I'm going to turn it back to you and Dr. Rakeman.
So Andy, are you back?
I am here, if you can hear me.
Perfect.
Am I
Yep.
back up on the screen? Yeah, so thanks, and I'm sorry for the technical difficulties. It seems like somebody's standing on the internet hose here at the office and slowing things down for us. But it does sound like you had a great conversation about how important it is to foster the kind of collaboration that we need, bring in this new kind of expertise. Really, I think one of the things that's been changing in this realization is how big of how hard of a problem pancreas cancer is, and how we really need to engage people from all across the way. And Lustgarten, I think from its inception, has really been a leader in terms of trying to engage the right people, bring in new thoughts, and make partnerships. And one of the longstanding partnerships that we've had is with Stand Up to Cancer, where we fund a group, what we should call the Pancreatic Cancer Collective, which has done a lot of work in understanding the disease and driving things towards clinical trials. And one of the exciting things that came out this year was a result from one of the clinical trials that we supported through the Pancreatic Cancer Collective, run out of Memorial Sloan Kettering here, which very similar to the work that you talked about that you're doing, Liz, is using vaccines to get the immune system ramped up to target the tumor, but in a different way and in a different setting. So I don't know, Liz, can you give us a little bit of background of what came out of this Sloan Kettering study led by Dr. Balachandran, and why that's exciting for us right now?
Oh, sure. So the study takes advantage of what we call neoantigens. So these are new proteins that the pancreatic tumor makes. And so as pancreatic tumors and other tumors too progress, they are making all these proteins. Just like they're making sugars, they're also making proteins. And some of these proteins are unique to an individual patient's cancer. And they're really haphazard. We can't predict what they will be, but we can take a small biopsy and we can sequence them. You heard from Dave earlier about being able to understand the different pieces within a DNA of the cancer. Well, we can actually sequence from a small piece of biopsy and find out what some of these new proteins, neoantigens, new proteins are. And new proteins are able to alert the immune system if they are presented to the immune system correctly. And so that's what vaccines do. Vaccines alert the immune system to new proteins. So that's why vaccines work against viruses, because viruses have these proteins that a human immune system never saw. Well, each patient's cancer makes these new proteins that the immune system hasn't seen. So basically what the investigators at Memorial Sloan Kettering did was they worked with the company that made one of the mRNA vaccines against COVID, because that's a great vaccine, shown to be safe, given to over 1 billion people worldwide. And it's very easy to change the proteins in that vaccine. So you take out the COVID protein and you put in the proteins that a person's cancer expresses. And that's what they did. And they gave the vaccine to patients. And these were people who underwent surgery, who normally would get chemotherapy afterwards and would have a pretty good chance they would have an improvement in survival, probably double what you would expect if you don't give any chemotherapy. And what they found was that these patients who got the vaccine first and then got the chemotherapy did a lot better than the patients who just got the chemotherapy. It was just a small group of patients, but it was very exciting to see that many of these patients didn't have the cancer come back quickly. And of course, that's the goal, to prevent the cancer from coming back in this case. And so now a bigger study is being designed and should be available to really see how powerful this vaccine approach is. Now, it's not simple because we have to get a biopsy and then we have to make the vaccine. So that could take, they told me when I've spoken with the investigators, about 6 weeks to make the vaccine, but that's okay because they get the tumor at the time of surgery and it takes about 6 to 8 weeks to recover from the surgery. So that's the goal. Once the recovery has occurred, we come in with the vaccine and we hope that the immune system is revved up. So this is really moving from vaccines that could be given to just anyone, so right off the shelf, to a vaccine that's personalized. It's made for an individual patient. And so we'll see. I think this could be a very important next step, but it's early. Again, all of this is early, but the excitement is there because in the past, we didn't have these tools. We didn't understand cancers. Now we understand pancreatic cancer a lot better than we did 20 years ago or even 5 years ago. So the opportunities have really expanded in what we can look at. And that's what Lustgarten has been doing. They've been funding new opportunities that are based on science they funded over the past 2 decades that we can now make real for patients, test these in patients, and hopefully have a good impact. I think we may have.
Thanks, Liz. Oh, am I lost again? So thanks, Liz. That's fantastic. And as you pointed out, it's as these tools are developing, it's really changing what's possible for us. And I think you heard that as a theme of whether it's new sequencing technologies are allowing us to reach deeper into genetics than we could before. New imaging technologies allow us to look at the whole organ and see how these early precancers interact and develop and are going to lead to new targets. New technologies in finding these novel mutant antigens and making mRNA vaccines and right. And as you point out, there's still ways to go with these, but the coming together of the hour point of the technology catching up with our understanding is really accelerating some things moving forward and making new things possible. We've heard already about understanding early disease and how that's going to help us early detection and interception. We heard a little bit from, I believe you're talking about PAS1 and organoids earlier, and the development of these vaccines helping us to not only like personalize, but almost hyper personalize, right? Like really tumor specific approaches to what drugs are going to respond to or how vaccines are going to work. And is really helping us drive that forward. And I believe when I was out, Dave was talking a lot about the labs and bringing in the new group at Salk, which is bringing new areas of biology to understand what's the next frontier of drug targets and treatments. And one other area that's come up that I think is exciting, it comes from outside of our labs program, but there was a really interesting and compelling study. I think it got a lot of press from NYU earlier this year, where working in mouse models, a little bit different from human, but they showed that exercising, putting the mice to exercise had some benefits, not only into the health of the mice, but in terms of how chemotherapy could work against pancreatic tumors in these mice, and did some real exciting work to find specific molecules and drugs that could mimic that effect to go forward. So I don't know, Dave, I know mouse models is sort of your bread and butter. It's where you've come out from. Do you want to talk a little bit about the work that Dr. Barsagi and her team did this year and why that's so exciting?
Yes, thank you, Andy. So as Dr. Rakeman mentioned, some 20 plus years ago, the first mouse models of pancreas cancer were described, and they have been useful for understanding some of the basic events that occur in human pancreas cancer. They have also been utilized for trying to understand therapies, both at the level of when do therapies work and when do therapies fail. Dr. Barsagi is very distinguished biochemist who's the dean at New York University. And she is an expert on a gene called RAS. And you heard from Dr. Jaffe that K-Ras is the gene mutated most often in pancreas cancer. And that can be used as a vaccine to actually intervene in patients before they develop pancreas cancer if a K-Ras vaccine can be utilized. There are also drugs against K-Ras that you're going to hear me talk about pretty soon. Dr. Barsaghi is a RAS expert. So she studied RAS for her almost entire career. And she naturally became interested in studying pancreas cancer when the models became available. And so she's made a lot of insightful discoveries over the last several decades about pancreas cancer using animal models. She discovered first that pancreas cancer cells steal. I talked about metabolism and how cancer is greedy. It steals things. Actually, she's learned that pancreas cancer cells eat the protein around them as a supply of food and a supply of amino acids, which that hadn't been described before in cancer. And so she's made just very insightful discoveries. The reason why that's important, that's led to new therapeutic approaches. Now, one of the studies that she was engaged in most recently that Dr. Rakeman mentioned is the mice that develop pancreas cancer, they get sick from pancreas cancer and they die from pancreas cancer. And so she had some studies occurring in her laboratory where she was asking, is there anything she can change about the mice, which weren't itself a new medicine or a new diet, but anything else she could change about the way they lived that would prolong their survival and make it so that cancer moved more slowly, expanded more slowly, et cetera. She made the surprising observations that if mice were exercised, meaning if the mice were put on a little wheel, just like you think of in gerbil cages, so they move around every day, that the mice would live longer. Now, when you make an observation like that, you don't believe it, so you have to repeat it. And so she repeated it many times, and it was always reproducible. And so she's a scientist, so she tried to understand what's the reason for this. And she also thought, well, better ask if that's true in patients. And so on the scientist side, she looked in the samples from the animals after exercise and before exercise, and she realized there was a new protein that was at higher levels in the tumors if the animals exercised, and the protein's called interleukin 15. And this allowed a light bulb to go off in her head because immunologists like Dr. Jaffe had been thinking that interleukin 15 could be an immune stimulant in certain contexts. It's been challenging to develop that, as is often the case, because it's, you have to actually deliver the molecule, not cause systemic inflammatory issues, et cetera. But Dr. Barsaghi made the IL-15 connection. And then her collaborators at MD Anderson came back to her and said, yes, the patients with pancreas cancer who exercised did better also. And so there were human data suggesting that a little bit of exercise helped patients with pancreas cancer. Didn't make the cancer go away, just allowed the patients to live longer and live better. And so then Dr. Barsaghi did cause and effect experiments with IL-15 in the mice. What if she just gave the mice IL-15? Well, it turns out they had a benefit. In fact, the mice didn't need to exercise anymore. You could just give them IL-15. What if you took away the IL-15 and you exercised the mice? There was no benefit. So these are the types of things that scientists do to show causation. Does your molecule cause the effect? Is the molecule required for the effect? And so this is the study that Dr. Barsaghi conducted. I heard about it some time ago. I was very excited by it. I said, you have to meet my colleagues. Turns out it was great. She actually knew Dr. Jaffe very well because they talk a lot about ways to make pancreas cancer go away. And Dr. Jaffe invited her to give a presentation to her esteemed group of colleagues who run the clinical trial program in the Lustgarten Foundation. And I think the presentation led to everyone else being excited, such that a clinical study is now designed that I'll ask Dr. Jaffe to say a few words about. But again, this is actually how things happen. Scientists have ideas, they have observations, they try to mechanistically understand it, make sure it's human relevant. If it looks good, then you test it. So Dr. Jaffe will tell you how she's going to test it.
Yeah, we're actually, I hate to say, but we're just designing it still. So, but we're hoping to be able to test it in patients who are starting out on chemotherapy. That would be the goal, I think. So.
Yeah, no, but I believe when I was off, you were talking a little bit about the Clinical Accelerator initiative, Liz, and how this type of study is exactly what we're looking for there, right? Where there's real good fundamental biology, there's molecules available, drug-like molecules or drugs that we can take into the clinic, and then working through this team to really understand how can we test that in people in a way that we can move it faster in a smallish number of folks, but collect a large amount of data and be able to take that forward and really learn not just about do these drugs work, but what is that going to teach us about the biology so we can do better next time, right?
Right, and to yours and Dave's point too, what's nice about this group is Dr. Barsaghi is a basic scientist, so she really doesn't know how to design clinical trials. So she comes to our team and we help her design the best clinical trial. And that's really critical too, because I think we want to make sure that the highest quality trials are being tested in our, highest quality trials are being conducted and the best drugs are being tested in our patients. So I think that's another benefit of our group.
Yeah, and I think again, coming up, grant funding, that it's not just giving money and letting the work happen, but setting up programs that allow people to interact in ways that they wouldn't otherwise, allow new ideas. And sometimes the best ideas or good ideas don't always come from the people with all the facilities to execute on them. As you said, basic scientists with good ideas for clinical trials need their clinical colleagues there. And then, so maybe a little bit sticking on this theme of collaboration and partnership and coming back to the K-Ras, it's been really great over this past year to see a new major player in supporting cancer research come onto the field, a group called Breakthrough Cancer that's led by Dr. Tyler Jacks from MIT, who you've already heard his name being invoked, who came out and wanted to make a big impact in cancer in general, but wanted to do it in the cancers where there's the highest need, and picking pancreas cancer as one of those that's most important, and picking the areas that are critical to move forward. And one of those, as Dave was suggesting earlier, is how do we get at targeting K-Ras, this gene that's mutated in 90% of pancreatic cancers. It drives pancreas cancer, and until very recently has eluded our chemists in terms of how to target it and how to turn this mutated protein off. But that's changing now, right? Or there's promise that's changing. So Dave, I know this is, K-Ras, getting at targeting K-Ras has been a passion of yours, a bailiwick of yours for a long time. Maybe talk about why the approach that Breakthrough Cancer is taking is differently, and how us partnering with Breakthrough has really helped to push our list and is going to make some great things happen.
Yes, thank you, Andy. So K-Ras is in many ways the heart of the pancreas cancer. It is mutated in most pancreas cancer tumors, and it is a gene. When it is mutated, the protein changes a little bit, but it changes enough to essentially be the dictator in the cell and alter the way the cell behaves. In the cell always behaves in a bad way, in almost like a truant type of manner, if you were to describe a child. So the cell does not follow the rules of other cells in a tissue. It acts like it's its own island, and grows, and makes progeny, doesn't respond to tissue parameters. So K-Ras has always been the target in pancreas cancer. We just haven't had medicines to go after it. Many of you are aware of the concept of personalized medicine. Personalized medicine was, I would say, first described when we had drugs that would target mutations that occurred in cancer where that mutation made a protein the drug worked against. So Gleevec for CML, erlotinib for lung cancer with EGFR mutations, et cetera. The K-Ras mutation has been one that the chemists, it's been hard for chemists to make a drug against it because when the protein is mutated, it works slowly. And almost every drug we have make proteins go slow, actually block the ability of the protein to work. We don't have drugs that speed up the way of proteins to work. That's just not how it works at the level of drug development. It turns out the chemists working on K-Ras have not given up. And they have not given up, mostly, I would say, because academics haven't given up. Chemical industry a long time ago had K-Ras drugs, but it never quite worked for a variety of reasons. They were going after the lipid tail of RAS. So as Dr. Rakeman was saying, it's always been an interest of mine to encourage people to develop K-Ras drugs. And in fact, the foundation itself has nominated K-Ras as one of its big targets over the past decades. We just had no way to really move the needle forward. We were approached by a new group that Tyler Jacks leads called Breakthrough Cancer, which is a group of 5 institutes, 4 of them clinical, 1 basic science, where the institutes had agreed to cooperate at a level which is unusual, where they would share ideas and share projects and have scientists go between each campuses to get things done. This is a, kind of a research context that Tyler himself had thought about for a long time, but can't really institute that in an individual institute because people have day jobs and they have to be committed to that. And so there's a group called Breakthrough Cancer, which was started where MIT, as the basic science place, would work with 4 clinical places: Dana-Farber in Boston, Memorial Sloan Kettering in Manhattan, Johns Hopkins in Baltimore, and MD Anderson, which is located in Houston. And these are, premier clinical institutes and MIT as a basic. And Tyler said that these 5 places will work together to solve big problems, and K-Ras is the problem. And so he came to us about 2 years ago saying, we're going to solve K-Ras. And I said, okay, we're interested in hearing more. And how are you going to do this? What's your magic wand? And he said, the magic wand is the people at all of these 5 places have access to part of the puzzle that together they're going to solve the puzzle. And none of them could do it by themselves. So some of them had access to model systems. Some of them had access to clinical samples. Some had the best biochemists on the planet. Some of them had these novel insights into how to interrupt K-Ras in their laboratories as well as in the clinic. We're willing to take these medicines into the clinic. And so I was all ears. And in fact, this was, about 2 years ago when these discussions started, because this would, take one of the, the objectives we had as a foundation and make sure we're working on it in real time. And so we had many discussions with Breakthrough Cancer. We, as a foundation, our job is to catalyze advances. And the best way is to, get people to work on the problems you think are the best ones. The folks at Breakthrough Cancer were more than willing. In fact, they had designed a project around K-Ras. And so Dr. Rakeman and myself got to play interlopers and hold their feet to the fire and make sure that, they have the best chance of actually solving the K-Ras problem as a chemical problem within the next 5 years. So this is a little bit distinct from Dr. Jaffe, who's going to use an immunotherapy approach. This is like to use the chemicals, the powders, the pills, the intravenous fluids to actually go after K-Ras in model systems that would be mice, tissues in the lab, as well as patients as soon as possible to see if these drugs can work. And if they can work, all of you on the telecon and all the people that with pancreas cancer, they'll be interested in these molecules because they would be targeted at the main mutation in pancreas cancer. What I can tell you so far is that as a foundation, we did agree to co-support this program with Breakthrough Cancer. Dr. Rakeman attends meetings several times a month where he gets updates on the progress. The groups are supposed to, are very candid with us about what the challenges that they have, excuse me, in the projects. And we've been encouraged by the data we've seen so far. And one thing I can point to, which wasn't published by this group of BTC investigators, but rather by another group of investigators at University of Pennsylvania yesterday, is there was a publication using the same mouse models that we talked about earlier, using K-Ras drugs, showing that these K-Ras drugs really had a profound impact on the cancer in the mouse, shrank the tumor down massively in a way that we would predict and hope for, that we would see also when it gets to the clinical stage. So I would say like all indications are very promising that K-Ras drugs are going to be a big deal. And I think this investment by the foundation is terrific, because I'm hoping that when a patient comes to see Dr. Jaffe in the clinic, when she says, what did the K-Ras drugs do to you? They'll say, it worked really well. And this is the data I have now. And she'll know how to use that information in advising the patient what else they should do to keep the cancer at bay and maybe make the cancer go away. So this is a huge deal that the Lustgarten Foundation is participating in. I'm hoping that it's going to really change the approach to this disease for all patients everywhere. But we have to do the science correctly so that that can be the case. And that's really what our foundation does, is we stand for the commitment that the science of pancreas cancer should lead to the best clinical outcomes for all patients everywhere in an equitable way. So Andy, I don't know if you wanted, or Liz, me to say anything more about this program. I'm extremely excited by it, obviously, and I'm hoping that you will start to see, clinical outcomes, from these medicines.
Thanks, David. I think what you said there at the end is really important. It's the science leading us to the best possible clinical outcomes, and that's really been the driving credo of the Lustgarten Foundation. Let's take what our patients need, find the right science to address to bring us to the right clinical outcomes. And as I started saying, what I've been, really excited for this year is we're starting to see that kind of long-term investment in understanding the science and the biology real payoff into differences for patients. We started off talking about, these long-term screening programs that we're now really being able to measure. Well, what benefit does it mean? What does it mean for a patient if you're in a surveillance program, and how much difference does that make? How does that help to lead us to thinking about Liz's first steps in terms of intercepting cancer, and also ask new questions about, well, how do we get to those other 80% of patients where we don't know a gene, but we know they're at high risk? How do we get to understanding how does a benign change in the structure of the duct turn into cancer, so we can know when to intervene? So again, new science is going to lead us to new impact later on. I think you hear that in terms of really being able to think about clinical trials that are targeting therapies to the specific patient and to the specific tumor, whether that's this, cutting edge technologies and mRNA vaccines being able to be applied specifically to a patient's own tumor. The very exciting work that both Dr. Tuvas and Dr. Jaffe are involved with the PASS study, and really trying to understand as completely as we can about a tumor inside the body, outside the body, grown in a dish, and using all that information to better target. As well as, I think a lot of excitement over this past year of bringing in new players, new ideas, new dollars that's really helping to accelerate the mission, whether that's through expanding our network of labs, expanding our network of partners with Breakthrough. So I think a very exciting year, and a year that ends us with a lot of momentum going into 2023. And you've heard about some of the new projects we're starting, some of the things that are getting off the ground. But maybe, before we close it out, I'll turn back to Dr. Tuvas and Dr. Jaffe, let you give your kind of last words on, if you had to pick one, nobody has a favorite child, but what really excited you about this year? And as I know you're both, scientists, and we'll always think about the next challenge even before we've, finished the first, like, where do you really see the effort and the progress to look forward to for? So maybe Dr. Tuvas, do you want to start off?
Yes. I think the study from Hopkins has really demonstrated that early detection matters. And now it is our job to extend the concept of early detection to all patients. The study that was published had to do with families that were at high risk. I think to extend it to all peoples, we will need to, think differently about this concept, in addition to the great work that you heard about today. And that's something I feel strongly about, and I know the foundation does too, and we will be seeking new ideas about this. And then if I'm not too greedy, I'm also, extremely excited about the new therapeutic results that Dr. Jaffe and her colleagues are producing. And so I'm just so hopeful that patients with pancreas cancer in 2023 will have a chance at second-line therapy, third-line therapy, fourth-line therapy, because you will be well enough to get those therapies, and the therapies will exist. But of course, I've now put the pressure on Dr. Jaffe to have the last word.
Yeah, I mean, this is just an exciting time. I've been doing clinical trials for 30 years almost, if you include my training. And I just remember, for so many years, I would have to say to pancreatic cancer patients, this is the first time I'm testing this therapy. It's not going to work in you, but you're helping other people. I can honestly say today that we could test a new therapy in patients, and we are seeing patients benefit. I could not have said that. And for those people who know me, I don't toot my own horn. I don't talk about things. I'm very cautious, but I truly believe we are on that, that border. We're on that phase where we're just about ready to take off like a rocket ship. We have so much data, so much science behind us, and we have so many people. We've brought so many people into the field with all the investment that Lustgarten and other groups have done to bring these amazing scientists into the field to work together. So I'm really excited. If there's one thing that I think we'll see a lot of progress in for sure over the next year, it's K-Ras, whether it's targeting K-Ras when it first turns on in pre-malignancy, or K-Ras, which is still there in metastatic disease. We now have targeted drugs. We have immunotherapies. We're going to see a lot of progress against K-Ras. And I'm very, very excited because that's been the big elephant in the room for so long. And finally, we have many ways to attack it, not just one way, but several ways to attack it. So I'm very excited about that, but I'm just excited being here at this time in our history to be able to really make a difference for patients. And that's what it's about.
Thank you both and agree. And I hope that everyone here feels the excitement from all of us talking about this work, feels the anticipation that we're on the cusp of something good. And I think, we have the momentum, as we pointed out, we have the teams of scientists, and Linda, with this community on the webinar, the community of supporters we have behind us, I think it leaves us no option but to succeed, but also gives us all the energy and the motivation to succeed. So I think, we thank you to everyone here for this opportunity to share this with you, and thank you for being part of this, and hope you continue to be a part of the success that we're looking forward to in the future.
Thanks, Andy. One of the webinar participants put into the chat commenting about the amazing humans who care so much about patients and their families and about pancreas cancer. And she wanted to thank all of you for giving patients and their families hope. And of course, the Lustgarten Foundation is so grateful to Dave and to Liz and of course for Andy's leadership, and for everyone, the SAB, the TAG, who are so critical to advancing our mission of transforming pancreatic cancer into a curable disease. But without the Lustgarten community, without people who are watching today, we always say led by Lustgarten, but powered by all of you. Your support is what makes all of this possible. And we hope that you'll continue to follow the Lustgarten Foundation, see what we're doing. Our next Lustgarten Live is February 15th of 2023, where we will be talking all things K-Ras and our partnership with Breakthrough Cancer. And we look forward to sharing that with all of you. We wish everyone a very happy holiday season. Everyone, please stay healthy, and we'll see you all in 2023. Thank you all so much.